Mr. Brewer here for physics week 6. We're already in week 6 of online learning. And what we're going to try to do in this one's sound and light, which is basically 3 chapters. A little bit lighter this week as far as the content itself. Trying to just briefly go over each chapter. So I'll hopefully only get through 3 videos or so of each one. First one, we're going to look at just what are waves and vibrations, since eventually that's what sound and light becomes. So sound and light and all kinds of waves come from a vibration. So what does the vibration come from? Obviously, it can come from an instrument, plucking a chord, come from throwing a rock into a puddle. Whatever will cause the vibration of movement is going to be what a wave is going to be produced. Something we talked about last week when we were doing periods, we were talking necessarily always about orbital periods, how much time it takes to go all the way around in one complete revolution. But it's also could be used as a pendulum, point it takes to go from point 1 back and forth to the original point you started from, or it can go as a wave. A period can still be the same thing. One point of a wave up, down, and then as it starts to come back up, one succession, the amount of time it takes to do that is still called a period. So we really didn't change anything. We're just adding to where it's from. So a couple of things that can be found in all waves. Crest, the highest point of the wave. Trough, the lowest point. The amplitude is the distance from the midpoint to the crest or trough. Shouldn't matter. They should be the same. And then wavelength. If you see that down here, wavelength is this lambda sign we end up using. A distance between any 2 successive points. So it can be crest to crest, trough to trough, midpoint to midpoint, whatever. It's still the distance of one complete wave. And the other thing we're going to need to know with any sound or light, we look at frequency. And that's how many crests pass a certain point per unit time. So how many cycles does it make? We talked about frequency and how many circular motion, how many times something goes around per second or per minute. Same thing here. Its frequency is how much time, but now we're looking at just the crest of the wave passing. Notice this is the same thing we did last week. We said frequency. There is between frequency and period, there is a relationship. They're inverses of each other. So frequency is 1 over the period. Period's 1 over the frequency. It's fairly easy. Very little math kind of that we put into this this whole week. So we look at wave motion. Can be a compression. You notice how that is beating. It's compressing the air molecules back and forth to produce the sound. There's light, which is another type of wave we're going to spend one video talking about, and it's electromagnetic wave. As you can see, it's up, and it's a compression between the purple, and then it's still an up-down. It's a regular wave that we would look at. It's a combination of both. One of the things, like we said, not only know the characteristics, but know the wave speed. And speed is a relationship between the wavelength and the frequency. So just the velocity v is going to be the lambda f, which is going to be the wavelength times the frequency. So here are the 2 types of waves that we will focus on. Transverse waves, more of that up-down. If I had the slinkies, I'd be able to show you. It goes up and down. It's a movement. Like I said, it's going to actually take movement, go up and down and move it. These are light waves. Light waves would have this. I said the up and down movement as it goes. The second type is a longitudinal wave. And if you take a spring and you contract it and then release it, it moves throughout as a compressional wave. This is what sound is. So those are the 2 types of wave, transverse and longitudinal. And when we look at them, they can directly be responsible for sound and light that we will look at. But they all have crest, trough, amplitude, wavelength, and frequency, which are the main things that you have to be able to know about each type of wave. Now, the next video I'm going to do eventually we're going to look at just sound, and then I'll do a third video that looks at just light. And then that'll be it for this week, and not much math involved in